Good day everyone! Welcome sa panibago nating tutorial series. So this is Information Assurance and Security 2 series. This is part 7 and for today we are going to talk about network controls, devices, and protocols. Network security controls are primarily designed to prevent any unauthorized user, application, service, or device from accessing network data. And at the end of this video, you will learn the elements of network security controls, user identification, authentication, authorization, and accounting. So let's discuss first the elements of network security. And we have here 5 elements of effective network security. So the first is identity. Identity is a accurate and positive identification of network users, hosts, applications, services, and resources is a must. Identity is the new perimeter in the cloud-native world. Ignoring that fact and simply allowing credentials without challenge or validation is just not a good practice, and it is one that could expose your organization to risk. With an identity in the form of username and password or access credential, a user or device can get access to service. In the hands of an attacker, the same identity grants the same access. And next, we have here perimeter security. This enables you to control access to the network applications, data, and services so only authorized users and information can pass through the network. And we have here data privacy. Data privacy is the providing of confidential data on command to authorized users while protecting the information from eavesdropping or tampering. Tunneling, encryption technologies, and protocols like IPsec provide important protection while implementing virtual private network. And security monitoring, you also should regularly test and monitor security preparations. By being proactive, you can identify areas of weakness and make adjustments so that when a real security event occurs, you will be ready. And policy management, it's likely your network will grow in size and complexity. You'll need a centralized policy management tools that use directory services to grow with the network. These tools define, distribute, enforce, and audit the security policy through browsers interfaces. Plus, they enhance the usability and effectiveness of your network security solutions. And we have here 3 security control functions. First, we have preventive controls. It describes any security measures that designed to stop unwanted and unauthorized activity from occurring. Examples include physical controls such as fences, locks, and alarm systems, technical controls such as antivirus software, firewalls, IPS, and administrative controls like separation of duties, data classification, and auditing. And detective controls, it describes any security measures taken or solution that implemented to detect and alert to unwanted or unauthorized activity in progress after it has occurred. Physical examples include alarms or notifications from physical sensor like door alarms and fire alarms that alert guards, police, or system administrators. Honeypots and IDS are examples of technical detective controls. And last, we have here corrective controls. Include any measures taken to repair damage or restore resources and capabilities to their prior state following unauthorized or unwanted activity. Examples of technical corrective controls include patching a system, quarantining a virus, terminating a process, or rebooting system. Putting an incident response plan into action is an example of administrative corrective control. So basically, network security access control, also known as network admission control, is the process of restricting unauthorized users and devices from gaining access to a corporate or private network. Network access control ensures that only users who are authenticated and devices that are authorized and compliant with security policies can enter the network. As endpoints profile rate across an organization, typically driven by bring your own device or also known as BYOD policies, and an expansion in the use of Internet of Things or also known as IoT devices, more control is needed. Even the largest organizations do not have the resources to manually configure all the devices in use. The outdated features of NAC or Network Access Control solution are sizable benefit, reducing the time and associated cost with authenticating and authorizing users and determining that their devices are compliant. Cybercriminals are well aware of this increase in endpoint usage and continue to design and launch sophisticated campaigns that exploit any vulnerabilities in corporate networks. With more endpoints, the attack surface increase, which means more opportunities for fraudsters to gain access. NAC solutions can be configured to detect any unusual or suspicious network activity and respond with immediate action, such as isolating the device from the network to prevent the potential spread of the attack. And we have here the goals of the concept, such as mitigation of non-zero-day attacks, authorization, authentication, and accounting of the network connections, encryption of the traffic to the wireless and wired network, policy enforcement, and identity and access management. So we have here user identification, authentication, authorization, and accounting. Identification is the ability to identify uniquely user of a system or an application that is running in the system. So basically, it is the process of ascribing user identifier to a human being or to another computer or network component. In computer system, specific IDs need to be linked to a particular authorized users of those IDs. Even inanimate components such as a network interface cards, firewalls, and printers need IDs. It's about processing an identify. Identification occurs when a subject claims an identify. For example, when I say, my name is DevTech, or a user can claim identify by username or user ID, and process can claim its identify by process ID, or an application can claim its identity by application ID. Example is entering username, user ID, or account number on a login page, website, or application, presenting your access card, or swiping a smart card on a device, and presenting your hand on a fingerprint scanner or face in front of a camera for access. Okay? So, authentication is the process of verifying the claim of identity. So, identification and verification is authentication to ensure the individual or the user is someone the user claims to be. It occurs when a subject proves their identity takes place before authorization. For example is for your identity is your username, and for verification is your password, so that you are authenticated to log in your account. The same with your credit card number as your identity and your PIN number as your verification. And we have two types of authentication: single-factor authentication and multi-factor authentication. Single-factor authentication, or also known as SFA, it is the simplest form of authentication. A user, process, or device must present a single form of identification. Example, use of a password to log in. And for the multi-factor authentication, or also known as MFA, authentication based on two or more factors, it is the strongest form of authentication. Example, use of a password, something you know, and a soft token, something you have to log in. For example, as you log in your username and password, there will be a text message that sends you your code to log in your account. So we have here authorization. It decides what an identity can access, level of access to a resources, or performs once authenticated. Authorization takes place after authentication, means of deciding what an identity can do or cannot do. For example, a user identity who wants to access an ebook enters his username and password on a web application offering the services. And the authentication is the web application captures the details and sends them to a backend server to verify the username and password combination. The server verifies the entries and approves the identity if the combination is correct, saying, yes, it is valid identity. And the authorization is that identity is provided to read access, obviously based on access level permissions is stored in the ebook database. So as per NIST or NIST, accountability is the principle that an individual is entrusted to safeguard and control equipment, keying material and information, and answerable to proper authority for the loss or misuse of the equipment or information. In simple words, accountability is the capability to hold the individual, I mean the one performing an actions, is accountable for its actions on the object. Example, database, file, system, or an application, and etc. Why we need accountability? Of course, to ensure that every information asset is owned by an individual in the organization who is primarily responsible for it and can be held accountable in case of an event. Accountability helps to ensure duties and responsibilities of an employees to carefully handle the information they use. Okay? And let's talk about cryptography. Cryptography is the study of encrypting and decrypting data to prevent unauthorized access. The ciphertext should be known by both the sender and the recipient. With the advancement of modern data security, we can now change our data such as that only the intended recipient can understand it. And cryptography allows the secure transmission of digital data between willing parties. It is used to safeguard company secrets, secure classified informations, and sensitive information from fraudulent activity. Among other things, crypto means hidden and graph means writing. Cryptography is classified into two categories based on the types of keys and encryption algorithms. It is the symmetric key cryptography or the secret key and asymmetric key cryptography or public key. So let's take closer look at each type. Symmetric key cryptography, also known as secret key cryptography, is a private key encryption encrypts data using a single key that the only sender and the receiver know. The secret key must be known by both sender and the receiver but should not be sent across the channel. However, if the hacker obtains the key, deciphering the message will be easier. When the sender and the receiver meet on the handset, the key should be addressed. Although this is not an ideal method because the key remains the same, it is simpler to deliver a message to a certain receiver. For instance, Reggie is sending message to Lundi that he does not want anyone else to see. He'd like to encrypt this message, that is simply because Reggie and Lundi exchange the same key. So they will use the same key for encrypting and decrypting. Here's how it works. First, Reggie encrypts his signals with his key and his message has now been encrypted and scrambled. So when Lundi receives the encrypted message, he decrypts with the same key so he can read it in plain text, okay? So next is asymmetric key cryptography. Asymmetric key cryptography, also known as public key cryptography, consists of two keys, a private key used by the receiver and public key which is announced to the public. Two different keys are used in the method to encrypt and decrypt the data. These two distinct keys are mathematically linked. The public key is accessible to anyone, whereas the private key is only accessible to the person who generates these two keys. For example, Ruben wants to send an encrypted message to Nikki, and they agree to encrypt his message using public key encryption. The receiver initiates public key encryption to encrypt sender's message. The receiver, not the sender, initiates the public key method to encrypt sender's message and everyone has access to the public key. The receiver Nikki is the only one who has access to the private key. And here's how it works. Step 1. Nikki generates two keys, one public key and one private key. Nikki stores the public key on a public key server that anyone can access. Step 2. Nikki informs Ruben of the location of her public key. Step 3. Ruben obtains Nikki's public key by following Nikki's instructions. Step 4. Ruben composes a message and encrypts it with Nikki's public key. And Ruben sends Nikki the encrypted message via the network. And last, the step 5, Nikki decrypts Ruben's message using her private key. Although Nikki's private key is confirmed that no one read or changed the document while it was in transit. And it cannot confirm the sender because Nikki's public key is available to the public and anyone can use it to encrypt his document and send it to Nikki while posing as Ruben. Hashing or a hashing algorithm is one-way process that converts your input data of any size into fixed length enciphered data. At the center of the process is where you'll find the hash function. Basically, you can take either a short sentence or an entire stream of data, run it through the hash function, and wind up with string of data of specific length. It is a way to hide your original data to make it as challenging as possible to reverse engineer. In more technical sense, it is a technique that uses a mathematical operation to shrink a random quantity of input data called hash key into a fixed length strings of bits in a way that is too impractical to reverse with modern computers. Here is a simplified illustration to show you what we mean. So we have here the message named myfile.txt and the hash algorithms, which is the SHA-256. And here comes the hash value, which is random text and numbers. So the length of the output or hash depends on the hashing algorithms you use. Hash values can be 160 bits for SHA-1 hashes or 256 bits and 384 bits or 512 bits for the SHA-2. They are typically displayed in hexadecimal characters and the input data's quantity and size can be varied but the output value always remains the same in the terms of size. Ayan. So that's it for this video and hoping na may natutunan kayo about introduction of Information Assurance Security 2. At kung may mga katanungan kayo, contact nyo lang ako through email or chat. Okay? So see you on the next video.